Good morning to one and all. And today we are here to demonstrate the capabilities of ArcGIS for Maritime Charting and ArcGIS for Maritime Mathematics. So before going into the product capabilities, have you ever wondered like how ships navigate from one location to the other location? What is the means or what is the source for the navigation and so on? So have you some queries, like do you have some doubts like what is the source that is used for the navigation, and do they have maps similar to what we use for the navigation of the Earth surface and so on? So yes, they do have maps for the navigation. So those are known as the nautical charts. And these charts are created using the International Hydrographic Organization specifications. So we have these capabilities with our ArcGIS software, which allows us to create, visualize, and maintain the database records of this nautical information system. So let's see what all are the products that are available with the ArcGIS. So we have two different modules, that is the ArcGIS for Maritime Bathymetry and then the ArcGIS for Maritime Charting. So two of these modules are used for the different purpose, but the final output would be used by the board, for the maritime sector in the highway. So if you see the maritime bathymetry, the bathymetry deals with the underground water surface. So it basically studies about the depths of the water or the depth. So it basically the water surface. And then when it comes to the charting, it is more focused on the water surface. That is the navigable water surfaces. So if you see the difference between the charts, you can clearly see the one is more focused on the elevation and the other one is on the surface. So let's start with the ArcGIS for Maritime Bathymetry. So what is bathymetry? So bathymetry is the study of underwater depth of the ocean floors or the riverbed, or it can be the lake floors. So it will describe us about how the terrain surface is below the earth surface. In other words, it can also be called as an hypsometry or the topography of the water surface. Now let's see how this data is collected and how it is recorded and what all formats is it available. So the first data collection method is using a sonar device. The sonar stands for sound navigation and ranging. So it is basically mounted on top of a ship or a boat, and it is allowed to collect the data, the sound waves that is received. Sorry for the disturbance. So I'll continue once again. So the sonar device will be mounted on the top of the ship, and this is known as the sound navigation and ranging. This device transmits and receives the sound waves. So as the ship navigates, it collects the data that is reflected, or it collects the sound waves that is reflected by the sea surface. So in this way, we would be able to calculate the depth of the sea waters. And if you see in these diagrams, we have different kinds of sensors that the sound waves that are being reflected. So all these waves are being collected by the sonar device, and which helps us to determine the depth of the sea. And not only the depth, it is also helping us to identify the obstructions. That is, if there are any objects below the sea surface, or if there are any ships that are submerged within the sea surface, all those kind of objects can also be identified using this device. And another way of data collection is using the lidar technology. So the lidar technology helps us to identify the data in the form of a raster. So once you have collected the data, it can be processed and the input can be provided in different formats. So let's see what all formats will we get after doing this survey. So we get two types of formats, that is the vector data set and the raster data set. So in the nautical domain, the vector is also known as the soundings or the depth values. This is nothing but a point data set. So a point data set has the information about X, Y, and Z. That is the latitude, longitude, and the elevation values. And further, we can use this point or the vector data sets and convert it into an elevation raster or the other bathymetric models that would be required for further analysis. And using the radar technologies, we can get the input as the raster format and which can be further processed as required. So let's see a quick demo of how to make use of this data sets for the further analysis. Now I will be showing you a sample data set which is collected and which shows the bathymetric values in that particular area. So I'm just enabling this sample data depth, and these are some of the sample data sets that are collected for measuring the depth of the water surface. So if you see this data, this is a vector data and it is very dense. So let me zoom into little so that the data would be clear and you will understand more about it. So as soon as I zoom into the data, you can see that the points are placed at the regular intervals. So these are nothing but the soundings or the depth values that have been taken at a specific location. So if you click on any of these points, you can see the information about it. So it has the longitude, latitude, and the depth information. So that at that particular point or at that specific location, you can see the depth value is about minus 3,000 meters below mean sea level. And if you want to know the distance between one surveyed point to the another surveyed point, you can quickly use the measuring tools to identify the distance between one survey point to the other. So it is approximately about 1.8 kilometers. So the 1.8 kilometers has been maintained to do this survey. So now using the basic tools of ArcGIS Pro, we can convert this vector data sets into a raster. So let me show you that. So by just using the basic point to raster tool, so you can quickly make a search by typing point to raster in your geoprocessing window, and you can create an elevation raster out of it. So here the input features would be the sample depth, which has the elevation values in it. Since we are generating an elevation raster, so we would choose the value field as the depth, and then the output raster would be in the specified location. So right now I'll leave it by default. And the cell assignment, you can assign the cells based upon the process that you need to do. And then the priority field, you can either set the priority field or leave it by default, and the cell size at which you want to generate the raster. And once you have filled this parameter, you can quickly run this tool. So since it takes little time, I have already done this for you. And this is the raster that is generated out of the sample datasets. And you can clearly visualize this raster and the depth information. So if I open this raster, you can see a color ramp has been created with the values ranging from 165 to 5,552 meters below the mean sea level. So you can even set the symbologies for the better visualization. So with the help of the symbologies that are available in ArcGIS Pro, I will quickly apply the classify symbology to show you the differences in the depth values or the distribution of the depth values. So here I can set the value or I can give the interval. Suppose if I want to classify it into 10, you can see that each color is indicating the depth values. So if you see, the yellow color is having the depth value less than or equal to 4,127 meters below the mean sea level. So either you can click on this to get the data values. Similarly, if you click on the red color, you can see that the value is ranging below 74 meters at this particular location. So in this way, you can easily identify where are the depth values, or where it is steep and where it is a plain surface, and so on. And now we have created a classified raster symbology. And for the better visualization and for the better understanding, you can perform some of the raster functions on the fly. So using the raster functions that are available in ArcGIS Pro, we can quickly generate the different surface models. So for right now, I would quickly generate a shaded relief, which will give us the better interpretation. So for this, you need to choose the input raster. So either it could be a point to raster or anything. So color ramp, and then you can set the hill shade type. Either it is traditional or multi-directional. And you can set the azimuth and the altitude angle. Based upon that, it will generate a hill shaded raster for you. So I'm just enabling it, and you can see this is the shaded relief, and which is giving us the better interpretation of where are the terrain undulations and where it is a plain surface and so on. So using this shaded relief, you can clearly understand that in some of these areas, there are terrain undulations, and if you go to the edge of this raster, you can see there are some of the terrain undulations, but at the center, you can see it is deep. And at this area, in this particular area, it is a plain surface. So now if you want to use it, or if you want to view it in a 3D, you can just go for a 3D scene and view it for the better understanding. So if you see through this, you can clearly get to know. So in these areas, there are some mountains, or it can be anything. So there are some undulations over here and over here, and this is the plain surface. So this is how it looks below the water surface. And finally, with the help of this raster, we can even generate contours by just running a geoprocessing tool called contours. So I'll directly search for it. So you can choose either of them from Spatial Analyst or 3D Analyst and generate a contour. So you can set the output values, and you can even set the interval. Like if you want to create it for 500 meters or 100 meters, you can set that interval and the contour type, whether you want to generate a polygon, line, so on, and run it. So as soon as you run it, you will get an output similar to this. So these are the contour values for this particular raster or for this particular elevation. And now you may get a doubt like why we are doing all this and how is it useful. So bathymetry is one of the important parameters for generating a nautical chart. So every nautical chart has the bathymetry information. So if you see this particular chart, this is how an ink cell appears, or how an ink cell looks. Ink stands for electronic navigation chart. So these are the depth values. The numbers, whatever you see over here, are the depth values, and the lines are the contours. So based upon the depth and the contours, the color is coded for the water surface. So in this way, this is one of the important parameters, and it is like one of the important inputs for creating a nautical chart. So now we have worked on the vector data. What if we are having raster data, and what if we want to create it for whole peninsular India? So in those cases, we will be having the huge data sets, and it will be a challenge to maintain this huge data set. So in those kind of scenarios, our ArcGIS for bathymetry, maritime bathymetry, will help us resolve that issue. So we have the bathymetric information system, which has its own schema to maintain the huge data sets. So here is that schema. where you can see we have a mosaic data set and all the relational tables. And using this, you can configure a mosaic data set which has all the bathymetric attributed grids. So it is not same as the mosaic data set. So this is different for the bathymetric information system, which stores all the bathymetric attributed grids. So let me zoom into this to show you how the data looks. So if you zoom into the location, you can clearly see these are some of the rasters that have been merged together as a bathymetric information system. And you can see the color code. So the red color is having the least depth values. That means among this, like whatever is available over here, the red colors are having the least depth values. So now we can use this raster for further analysis. Either if we need some depth values for this raster, we can convert from the raster to the vector, or we can interpolate this raster for further analysis. So now using this bathymetric data set, we perform different kind of analysis. So let me show you one of such analysis which is created using the bathymetric data set. So here if you see, we have one of the analysis which is done using the bathymetric data set. So this is known as the dredging analysis. So what is meant by dredging? Dredging is a removing of the accumulated silt or sand on the sea surface or the riverbed. So that process is done with the help of using the bathymetric information system. So here we have taken the port area as the sample data set, and we are working on it. So let us see how the bottom of the sea surface or this port area looks like. So this is the bottom of the sea surface. So this is how it should look like. It is clear from the silt and the sand. So let me show you how it looks if the silt gets accumulated. So you can see all this white color regions, like white color patches, are the areas where the silt got accumulated. So now we need to make sure, in the sense the port maintenance or the harbors needs to make sure that this navigable route should be cleared from all kinds of obstruction. So in those scenarios, it is important for us to identify these areas and extract or, perform the dredging analysis. So using the cut and fill analysis tool, we have identified the areas that needs to be dredged using the bathymetric information system. So these are some of the areas like where the dredging needs to be performed. So the white color patches are the areas where the silt got accumulated. So now to make you understand in a better way, I will show you the comparative analysis between the before silt and after silt, like before dredging and after dredging. So here we have some of the comparative analysis tools using which we can understand how it looks after finishing the dredging process. So this is how it should look so that this way will be safe for the navigation. So this is one use case that has been created with the data set. In the similar way, we have multiple use cases or multiple departments are using this bathymetric information system or the bathymetric data sets. So the first main end user of the bathymetric information system is the hydrographic offices. So hydrographic offices use this information for generating the nautical charts. Either it can be a paper nautical chart or an electronic navigation chart. And then the oil and gas industries. So this bathymetry information system will be used during the mining process. So during mining, we need to deploy, like the oil and gas industries needs to deploy so many missions in the seabed or in the right location. So for that, they need to understand the depths in that particular area, so that they can deploy their missions in a better way without any risk. So those industries use the bathymetric data sets and obviously the missions And as we know that submarines navigate under the water surface, and since the body of the submarine is very huge, it needs the large area of clearance. So that clearance is also provided by the bathymetric surface. And finally, we have many more industries which are making use of the bathymetric data sets, such as port, as I have shown you, coast and marine spatial planning, coastal engineering, habitat mapping, and so on. Moving on to the next presentation. So next we will be talking about the ArcGIS for maritime charting. So as we have seen about the bathymetry would be one of the inputs to the maritime charting. So this charting is totally based on the on-surface navigation. So let's see what is maritime charting. So ArcGIS for maritime charting is a complete system for managing maritime data and products. It can be used for the creation and maintenance of standard base nautical charts such as ENCs, IENC, and so on. So coming to the specifications, so we totally support the International Hydrographic Organization standards that are S57, S52, S58, S63. So these standard formats are used for the different purpose, such as S57 is used for transferring the data among the hydrographic organizations, and it can be updated based upon the time, and it is easy for the hydrographic organization to share the data in this particular format. And when it comes to the rivers or lakes, it is known as inland electronic navigational charts. And then we have additional military layers. So all these formats can be generated using our ArcGIS software. And then the S52 is the symbol library. That is again the specific format, specific standard by the IHO, that is the International Hydrographic Organization. And for the validation purpose, the data, the S57 cell needs to be converted into S58 format so that it makes sure that it goes through all the validation process. And finally, we generate an S63 product out of it. An S63 product is an encrypted format that is used for the real-time navigation. So these are the data sets that are being used for this long, but right now the International Hydrographic Organization is going for creating the S100 series products. So it is also like we can even say that it is an advancement to the S57 products. So it has a wide range of products in the S100 series such as S101, S102 and so on. So even they are used for the different kinds of purpose. And the ArcGIS software has also the capabilities for creating the S100 series products. And at the end, the digital nautical charts, which were used very earlier before the electronic navigation charts. And coming to the capabilities of the maritime charting, so we can ingest the S57 cells directly into our database with the help of the tools that are available with the maritime charting. And we use the S52 symbol libraries for symbolizing the S57 cells. And we can publish as we are updating, like we can keep on updating our database, and as we are updating our database, the charts change similarly. And these charts can also be updated and also be published to our servers for the wide range of use. And at the end, so these all are some of the standards that we are generating as of now, such as additional military layers, IENCs, digital nautical charts, ENCs with S52 and S4 standard formats. So now let's see a quick demo on ArcGIS for maritime charting. So before understanding or before knowing about a nautical chart, it is important to know how this data is stored. So this data is stored in a nautical information system, and as you can see on the right, this is the nautical information system data model. So this contains all the features that are required for generating an S57 cell. And this is again the IHO specific standard format. So it is coming along with the ArcGIS for maritime charting. So if you have an ArcGIS for maritime charting, you are ready to create the nautical charts, or you are ready to start exploring or importing the nautical charts that are available to you. So this is the data schema of the nautical chart. So using this, you can make sure that you are generating specific chart that is suggested by the IHO. So once you have imported the S57 cells using the tools that are available, you can read those files in this format. So this is how an S57 chart looks like. And this chart will be used for the real-time navigation purpose. So this has all the information such as the depth values. So as we have seen in the earlier demo, the depth values are one of the parameters for this nautical charts. And then the contours, and if you see some of the lights, so these lights are used for the navigation purpose in the real time, and there are routes that are specifying the safe navigation that are used for the navigation purposes. So now we have seen the S57 cell, and with our ArcGIS tool, we have the capability of creating the S101 series products as well. So with the ArcGIS for maritime charting in the ArcGIS tool, we can create the data model. So this is again a new data model that has been come up for the S100 series products, and this data model can also be created with the help of the tools that are available with us. And once you load this data with the help of the maritime tools that are available, so if you can see in the maritime tools extension, so you have an option for converting the S57 cell to S101. So as soon as you convert the S57 cell to S101, the data will be converted into the S100 series products. And you can see this is one such data set that has been converted. So if you have seen earlier, I have shown you the S57 format of it. So this is the S57 format of that data set, and the same data set has been converted to the S101. So this is an S101 product. So now once you have created these products, you can even make use of the ArcGIS server, the maritime server capabilities, to publish it as a service and to make use of it, or the wide range of audience can make use of it. So let us see how it can be accessed as a service. So once you publish it as a service, your service will look like this. You can just use this service and add it to a map and create an applications out of it. So just go to the add and say add layer from the web and add this layer to your map. And once your layer or your service is added to a map, you can see the in cells, all the ENC cells will be added to your map. You can see there are multiple cells. There are some thousands of cells within this extents. So now, once you have done it, you can zoom into it to see the data within that. So if you are having some thousands of data sets, it would be difficult for you to retrieve the information, such as if you want to perform some query or if you want to extract the information of any cell, then you need to perform some queries to extract that. So for that, we have some applications that have come up with the maritime server, and using which you can retrieve your information very quickly. So here we have some of the widgets which help you to identify your data, or you can search your data very quickly. So just either you can use these tools, or by clicking on using these tools, you can click on any of the features or any of the surface to get the information about that particular feature. So if you are new to the maritime domain, you need not worry about it. So you can just use this identify tool and click on any of the objects. you will get all the attribute information. So as you can see, I have clicked on this plain area and it says it is a navigational system of Mars area, and it is also a part of the coastal area. And if you want more information about it, you can see all the attribute values. If you are aware of maritime domain, then you can understand about this, the L name and MAR systems and so on. And then if you want to change like the depth values for the navigation and so on, you can do that as well. So just by changing the contours and everything. So let's say I have my own ship that is being registered and I want to change the shallow contours or the depth for the navigation, for the safe navigation. So in that cases, you can just change the safety depths and apply, and your charts change accordingly on the fly. And if you want to visualize this chart during the night or during the dusky and all, so you can perform those kind of symbolic things as well. So just by clicking on the night, your chart will change accordingly based upon that night scenario. In this way, you can perform different kinds of actions, and if you are using it for any intended usage, such as for hardware or everything, you can just enable it and run it and see how the chart look like. And finally, if you want to export it or if you want to create a product on the fly, so we have some of the tools for generating the products on the fly. So that is known as the product on demand. So using this product on demand application, you can quickly select an area of interest and export a nautical chart for that particular area. So here, just by clicking on this widget, you can select any area of interest. So let's say I'll zoom into any of this location and I just need to click in this particular location. As soon as you click on it, you will see that the record will be added. So if you see this red color boundary, this cell has been added to my map. So to the print immediate, so I can just click or type a name for it, give a name for that particular chart and say print. So as soon as you print it, your product will be downloaded and you can visualize it. So if you see, this is one chart I have just downloaded. For the demo purpose, it has all the information such as the voice, the navigational routes, the depths, and if it has any metadata along with it. So all the metadata information will also come along with it. So in this way, you can make use of the maritime charting capabilities to generate the nautical charts that are the IHO specified, or you can even create the mathematic surfaces for different kinds of analysis. So now going back to the presentation, the next one is on the real-time integration in ArcGIS. So till now you have seen the maritime capabilities of ArcGIS. Now let's see what is the value addition that it can bring by integrating the real-time feeds. So now I will hand over the session to my colleague Prashant and he will be taking over this. So over to Prashant.
Yeah. Thank you, Sarika. So let me start with different use cases of real-time integration by different industries who uses maritime applications. When a platform like ArcGIS allows us to integrate real-time information along with powerful maritime options, which you just saw by Sarika, what she explained you on different products like product on demand, ENC charting, etc. So it opens up many use cases when we integrate real-time capabilities. So these are some of the use cases typically a maritime industry uses. So tracking, visualization, and monitoring allows us to identify the current position and other information on each vessel and track them appropriately. It also uses typically for situational awareness, like you can integrate the satellite AIS data or dynamic AIS data, or it can it can integrate with the terrestrial AIS data as well. So superimposing it on the ENC charts, it will bring a different perception, and it allows us to have situational awareness and decision making support. This also helps us bringing various data sources together, including charts. You can superimpose weather feeds. From the satellite AIS data, we can detect the piracy. So piracy data also can be integrated. Terrestrial and dynamic AIS charts also, AIS information also can be integrated together using the real-time capability. Now, when we have these data sources on board, we should have analytical capability. So not only just data interoperability, it also allows us with big data analytics and capability, because these data sets generally are coming in huge volume, and we should have a distributed computing mechanism to analyze these data sets. So some of these examples like vessel density or historical data analysis, whether the charts are being followed, the safest routes or safest channels are being followed, such monitoring systems can be run, and historical records can be recreated how a specific vessel was passing through. So it also helps for creating or planning voyage operations, bringing forecasts. So there are different agencies who provide these forecasting data. These data sets also come in real-time mode, so we can integrate those forecasts through real-time data feeds. It also allows us to detect piracy. So piracy detection using satellite AIS, or we have options to do alerting. So alerting possibilities are some of such use cases. And there are other use cases like analyzing commodities. The commodity traders and investment firms use AIS data to analyze commodity markets. It also allows us to monitor illegal activity and compliance. So different agencies have different compliance imposed on a specific geography. We, depending upon that, we can have those specific boundaries or the data layers in GIS, which allows us to have a multi-criteria analysis. So monitoring illegal activity and compliance is another use case. It also being utilized for identifying illegal fishing. Specifically when we integrate the terrestrial AIS data, or if they are registered with IMEI, then the satellite AIS data also, as AIS, what we call, that also helps us to integrate and find out the illegal fishing. It also allows us to identify or analyze emissions from these data feeds which is coming in. So there are agencies who provide such data sets along with the tracking of vessels. So that can be brought in into GIS, and we can have an analytics engine run on top of that. So there are algorithms in ArcGIS which helps you to do such analytics. It also helps us to find out optimizing fuel efficiency by optimizing routes and route planning with the integration option of ENC chart. We can do that optimizing plan, and it allows us to analyze the maritime product performance, like product manufacturers on the commercial aspect of it can use AIS data to study how their products can perform over long time periods. Analyzing a ship coating product by looking difference between ships that traveled on a saline water, or if it is on a freshwater navigation thing, then it can have a comparison. So we can have the charting options for the inland waters also, and bringing such terrestrial AIS information also on board into ArcGIS. And when we have these kind of use cases, or to achieve these integration along with maritime charting options, we should need real-time AIS data feeds, because that is a primary data source along with the ENC chart option you just saw. So what are those kind of data feeds what we generally get, and from where we get such data sources. So there are different agencies, government, open source, or commercial agencies who provide vessel traffic service (VTS). Uh, it is generally in the form of automatic identification system (AIS). So some of these are from the open source or government hub. It is AIS Hub, Cruise Mapper, and Sail VX, etc. Or for specific countries, we have uh, these options of Marine Cadastry for US, Helcom for Baltic Sea area, Ship AIS for UK, uh, then we have MSA for China, DMA for Denmark. So these are different government agencies who provide maritime information or AIS information for specific areas. And AIS Hub and Cruise Mapper Sail VX are global feeds, which is available either from government or open source. Now, some of these datasets may not be appropriate for specific use cases, or may not be containing all required information. So in that case, there are options of commercial subscriptions. So different agencies provide global. So all these commercial data sources are global data sources who provides AIS information. So Spire, Marine Traffic, Vessel Finder, Exact AIS, Fleetmon. All these organizations provide different API expose. They expose their APIs to subscribe to their AIS feeds and consume those on top of various applications. And GIS as a platform, ArcGIS allows to have an integration to these data sources. So now, when you have these voluminous data feeds, how you integrate it with ArcGIS? That is the question. And what are the options available as a platform provider Esri has put forward to the users or to the user community? So we have two different options. First option is along with ArcGIS Enterprise. In our earlier sessions, we have covered on this specific product or a specific role of real-time option, which is called Geo Event Server, along with ArcGIS Enterprise, which allows us to ingest and process voluminous data feeds from different data sources. So in this specific use case, it can be AIS data feeds, or it can have connection to other data sources like IoT or real-time information sensors. So these data feeds can be ingested by having out-of-box connectors in the system, and it can be further utilized to process it further and store it or visualize it or disseminate it appropriately to the user community in different formats. It can be consumed on a desktop environment or web environment or mobile environment, or it can be integrated with different APIs to have a customized product for your organization. So Geo Event Server is one of the option for connecting to the AIS feeds and bring that along with the ENC chart options or the maritime products what you saw from Sarika. So how you do that? You should have as a real-time engine, it should have three specific sections. One part is for the ingestion, and second part is for the analytics, and third part will be for the dissemination. So we have out-of-box connectors which helps us to connect to different data sources. So as I mentioned, these open source government or open source data feeds or data providers of AIS or the commercial data providers will expose their APIs in different formats. It can be GeoJSON, JSON, XML, or they push it through some REST endpoint or through TCP or UDP sockets. So we should have or WebSockets. So we should have a capability to read these data feeds into the system, and with out-of-box connectors, GeoEvent Server allows you to subscribe to those feeds and get the real-time data on board. Now, the second part of it, the geo event service part, where we integrate, okay, these are my data feeds, and these data feeds are having these kind of data sets, the schema. These are the incoming data types, the columns which this is what the data contains. I define that. Then I filter it, or I want to create some triggers. I want to do some geofencing or other analytics. There are out-of-box functionalities using our out-of-box processors, and I define that as a workflow. Then the output connectors, which is again out-of-box, like I want to push this as a stream service, so that without even a nanosecond delay, as soon as I receive the data, I disseminate the information on my dashboard for monitoring, or disseminate this data into a web application to visualize the data feed, or if I'm configuring it for creating some alerts in the form of SMS or email, I can configure it to disseminate to the appropriate person. So these are all out-of-box systems available, the input connectors and output connectors available in Geo Event Server to configure the appropriate data feeds and the processes and the destination system. Apart from this, we have our own Esri gallery and the partner gallery. You can see in the slide, this allows, these are actually custom made connectors. Say, for example, if you take Exact Earth AIS, or even for Spire, we have a connector available. So these are all AIS data feeds, which can be you can see on after the Rabbit and MQ, there is a AIS connector, input connector. This will directly read these AIS feeds, which is exposed by different communities, whether it is government agencies or private. If you have a subscription to it, will get read it, and once it is read, that can be processed and disseminated appropriately. And you can have a storage. So we have our own spatial temporal big data store as a elastic search option available, and a storage option available along with the ArcGIS Enterprise stack. Otherwise, you can store it in your normal RDBMS system or other cloud storage options as well. Now, from that, you can further utilize these data sources for your analytics. So these are different options. So as I described you, how we define the geo event service but this green color, this is an example which I want to explain you how we generally configure the workflow. So the green color box is the input. It can be n number of inputs or the input data sources, and the yellow boxes are out-of-box processors, and the light blue color boxes are the dissemination system. So it can be a stream service, it can be a feature service, what we expose this incoming data after processing. And once that is being done, then we generally disseminate this information on a dashboard. Operational dashboard is out of box available in the enterprise system as well as ArcGIS online system. Now, the second option for bringing this real-time data feeds in ArcGIS platform is a product called ArcGIS Velocity. ArcGIS Velocity is a real-time and big data processing and analytical capability of ArcGIS Online. It enables you to ingest, visualize, analyze, store, and act upon data from various sources, including AIS. So high-velocity event data can be filtered, processed, and sent to the multiple destination, which we saw in the Geo Event Server part. So it allows us to connect virtually to any type of data stream and automatically alert personnel when specified conditions occur. So the difference between Geo Event Server and ArcGIS Velocity, Geo Event Server is specifically a on-premise deployment with ArcGIS Enterprise. In the other case, ArcGIS Velocity is a subscription model, and it is a SaaS model sit on top of ArcGIS Online organization. So this is the basic difference. One is a perpetual model and on-premise model. You can deploy it on cloud. That is a different scenario altogether, but that is a on-prem model. ArcGIS Velocity is a subscription model, which also allows you to subscribe to ArcGIS Online and do an add-on licensing of Velocity, so that it allows you to connect to IoT platforms or AIS platforms, then do your big data analytics also on a SaaS platform as a subscription model. So these are two options available to bring your AIS data on board along with your maritime products, what Sarika was explaining you. Now, after this, let me explain you or showcase you some of these capacities. So I'm switching to the demo directly. So I have my ArcGIS Enterprise deployed, and I have my Geo Event Server deployed. So this is the Geo Event Manager page in which you will be configuring the data. And so here you have an example. See, I'm very simply subscribed to AIS feeds of Spire, and I am simulating this data through my stream services and consuming inside my web application. So this is a simple one-to-one connection. I didn't add any processing components into it. You have options to do filters and processors. In this will help us to do further processing information of AIS incoming data and what I need to see in my output. Now, I have a web application configured in which I'm starting my streaming. You can see the live AIS information is coming. This is a global feed. You can see the timestamp which is coming in and what kind of mobile, what is the MMSI number, what is the navigational status, the other parameters which that data provider generally gives. All that information is coming on a live mode here. So this is typically for streaming the data, and in the stream, this is all configured application. So here you can have a spatial filter if you are interested only for Indian Ocean. You can filter, you can have a spatial filter, or if you are interested in a specific vessel like the cargo ships, so you can filter by a specific area or by specific attribute that can be filtered out. Now, additionally, the organizations like Spire or the commercial data providers also provides us with the live or active channels through the vessels are traveling. So I have some examples of global shipping routes by Spire. So from the Spire, I have subscribed and I am getting all the live or the busiest channels which is being calculated and superimposed on top of my AIS data feeds. You can see these are the busiest channels in the global scenario. So that will allows us to understand the busiest route or any other analytics for that case. Now I am superimposing additional information like I stored this Spire data feeds which is coming, and using my big data analytical capability, I calculated the counts, the density of the vessels which is coming in. So I can superimpose that. So I can identify. So this is the density of specific vessels which has come in. Now I will be able to superimpose the ENC chart which Sarika was mentioning. So here you can see when I superimpose the ENC chart, I will have the option of increasing and decreasing the transparency so that I can make this visible. And when I superimpose this specific density analysis and see the safest route which it follows in the ENC chart, when I superimpose it one layer to the other, it will give me more perspective or a situational awareness of it. Okay, it is following the same safest channel generally, and any other information like the bathymetry information, the depth information also available along with my real-time data. So along with the real-time data feeds, the routes, active routes, and the analytics of the density calculation, etc., I can superimpose one on top of other. Also, I can superimpose the weather feeds on top of it to have a prediction model run. So on a web platform, it is giving you an end-to-end solution to have both maritime data integration, real-time data integration, and a complete decision-making system. So this is what the product capability as such available, and we urge you all to either join or follow us on GeoNet community to connect with us or collaborate with our technical members so that you can share your experiences. You can have an interaction with our team so that we will be happy to help you in the technical challenges. So this is a platform which allows us to have better collaboration and connectivity with the user community.